No, thanks for you guys for joining us today. I'm going to talk about my experience of building a new social network recently. I think this was last year, and how I used serverless and GraphQL and built an entire backend for a new social network in about 4 weeks. So this was a work I did for a client project where it was a new social network that lets you, mostly for university students in Belgium, register your sporting interest with and find other people to do sports with. So you can arrange things like basketball match and have a group chat. You can chat, you can private message each other, and you can arrange doing, say, sporting activities together, like jogging and stuff like that. The client was privately funded. It was bootstrapped, so there's a lot of constraints on money and therefore development time. And they also needed something to be done pretty quickly because they wanted to be in place before the new semester starts in universities. And so from the get-go, I pretty much had really good goals to work with and to help me make my technology decisions and what approach I should take. Because the client wanted it to be done quickly. They wanted something scalable in case the app takes off, and they wanted to be low maintenance, and they also wanted to be cost efficient, even as we scale to have millions of users. So pretty typical client requirements. We want everything, and we want it cheaply and quickly, as you do. So the team had 3 engineers, including myself, and at the time I was working part-time for this client, maybe doing 2 to 3 days a week, and for about a total of, I'd say about 4 weeks on this project. And we didn't just build a mobile app, and we also built a CMS system as well, which was used by the founders to onboard new universities and also to help them manage the metadata in the app, things like what sports you can select from. And then the CMS is also used by the university staffs to manage their profile and to also publicize their sports program for university students to sign up to, say, badminton classes, to spinning classes and things like that. So I'm not going to show you the full architecture because there's just a lot of repeated line items, but here are a few of the sort of key components. So everything was hosted on AWS. We have CloudFront and S3 for image assets and videos and things like that. And for authentication, we used Cognito. There's one Cognito user pool for the mobile app, and then there's a separate one for the CMS system. And the backend is all done in GraphQL using AppSync, which again, we have one for the mobile app and the one for the CMS. And they each have resolvers that point to different DynamoDB tables for mostly simple get and put and queries. Anything more complicated than that, I typically have a Lambda function resolver, and that function might do something a bit more complicated, but usually they're doing something against DynamoDB, but maybe multiple steps, which you could also use a pipeline resolver instead of Lambda for a lot of these multiple steps resolvers. But I think it's just easier for me to do them with Lambda. And also it's easier for me to hand it off to somebody else later who may not be familiar with VTO. And we also used Algolia for search. And Algolia is probably the closest thing you're going to find to serverless Elasticsearch. And to get the data in the DynamoDB tables into our Algolia indices, we use the DynamoDB streams to trigger Lambda functions. And then that function is going to synchronize any data changes from DynamoDB to Algolia. So whenever a user creates a new profile or updates their profile, or they say start a new activity in the app to say, I'm doing a basketball match on Wednesday, who wants to join me? That kind of thing. All of those changes are synchronized to Algolia so that other people can go into the app and search for, is anyone playing basketball, around me? That kind of thing. And I also capture a lot of business intelligence type of events from different Lambda functions. So whenever we creating user profiles or updating user profiles or creating new activities in the app, all of those are translated to business events, and then they'll be recorded and ingested by a Firehose delivery stream, and then they're buffered and batched into S3 so that we can analyze them using Athena. And we have a few, I guess, the daily jobs that query the data in Athena and look for people who is partway through the sign-up process, for instance, and then just tell them to come back and complete the process. Or if they were interested, they told us that they were interested in the basketball match, but there wasn't any available at the time. We also tell them that, hey, here's someone near you is planning a basketball match. Would you be interested? And again, this is not the complete architecture diagram, but it's a high-level summary of the services I used and how they kind of fit together from a high level. The full architecture diagram is just going to be a lot more lines between AppSync and DynamDB and the Lambda functions. And stepping up, I guess, another level in terms of the AWS environment itself, I also configured an entire AWS organization with multiple accounts and following AWS best practices with this kind of stuff. So that was all done within just a few weeks by me, one person working part-time for a couple of weeks. And it's only possible because I could stand on the shoulders of giants, and really all the hard work is done by AWS and the different service teams, and I can rely on pretty good tools like the Serverless framework to help me manage and deploy my application as well. So a bit about myself, I've been using AWS since 2010. So at this point, it's been more than 10 years now. I become a Serverless Hero in the 2018, and nowadays I work with Lumigo as a developer advocate, maybe half my time. And Lumigo is the best troubleshooting platform for serverless applications on AWS. And the other half of my time, I work as an independent consultant where I help other companies, such as this client, deliver their products or give them advice or give them some training via workshops. And personally, I've also been running pretty much entirely serverless since about 2016. And Gerard and myself, I actually put together a new AppSync course called the AppSync Masterclass. So check it out if you want to learn about AppSync. And we're actually going to show you how to build a Twitter clone from scratch using AppSync and Vue and Lambda and so on. So I guess this is probably one meetup group where I don't really need to explain what GraphQL is. You know the drill. You got your GraphQL schema, you've got your GraphQL server, and that server is going to resolve your query and get data from different data sources. So where AppSync comes in is that AppSync is a managed GraphQL service that plays the role of the GraphQL server, and you're able to just configure your schema and then say, this resolver points to DynamDB table, so we're going to make a get item request against DynamDB, or we're going to invoke a Lambda function. You can also connect AppSync to Elasticsearch. That's the Amazon Managed Elasticsearch, or Amazon RDS to an Aurora cluster, or as well as to any other HTTP endpoints that you have. So those five different data sources are all supported out of the box. So for example, as a logged in user, I say I want to fetch my profile. And so it's, in my query operation, I'm able to fetch everything, including my ID, first name, last name, gender, what sports I'm interested in. Those are all going to be coming from one table in DynamDB. So AppSync would do this get item request against DynamDB from the profiles table, and then it's going to identify me using the user ID, which is included in the JWT token that the front end sends to the backend. And the user would have authenticated against Cognito already, and that's how they got the job in the first place. But then the list of sports in my profile, they're just IDs, because we don't want to have to copy the entire metadata about the sports, the display name, the image we're going to show whenever we show the sport. So those data are kept in a separate table. And so with GraphQL and with AppSync, we're able to just use a nested resolver to fetch data from the sports table. So whenever I'm fetching my profile, I want to see what sports I'm what sports I do, and for each sport, I want to get back the display name as well as the image URL for image to show in the UI. So this is all good. The user can make one request, and you don't have to make multiple round trip. That's one of the benefits of GraphQL. And in the previous talk, we talked about, we heard about the N+1 request problem, and also we also have to think about how do we limit the amount of data the user is able to retrieve in one go. We can talk about that in a minute. And as for the activities I'm interested in, or the ones that I've arranged myself, I can have many activities. So when I fetch my profile, I just need to fetch the first page of my activities, which in this case, we want to see the next lot of activities that I want to do, which is likely all I want to care about, to see what are the upcoming activities that I've got going. And so again, we can use AppSync to run a query against the activities table where all the data is stored against my user ID as the hash key. And then this table would have the timestamp of the activity as the sort key. So we're able to, in this query request, get the activity back in descending order in terms of time, so that we're able to get the next, the most recent activities first. And if other people want to join my activities, we also have to fetch any requests as well, so that if someone saw my activity on the app and say, oh, I want to join your basketball match next week, then I want to return those requests when I see my profile, so that I'm able to approve them or reject them, and or have a chat with those people who wants to join. And again, we only store the user ID in those requests. So to display the actual user in the UI, we have to then fetch the user's profiles from the profiles table. And this is, again, we can use another nested resolver to get more data from the profiles table. So it's all very flexible. The client can basically ask for any information they want in one request without having to make multiple round trips. But it can also be dangerous as well, because the client can end up asking for more information than they need. And so you can have very deeply nested queries that can maybe start to impact your performance as well as for your cost, because and every time you're going to DynamDB to fetch some data, that's going to cost you, because when you're using DynamDB, is everything you're paying for the individual requests. So luckily, you can mitigate a lot of this by enabling caching in AppSync, which allows you to control. You can also enable caching on specific resolvers. You can also adjust the cache TTL for each of those resolvers as well. It doesn't have to be just a full body request and cache against that. And also another thing we do to sort of help mitigate, to reduce the amount of nesting that's possible, is, and also to help prevent any PII data like date of birth and other things like that from being leaked and shown to other people. We have a different type of profile type in our GraphQL schema. So when you are fetching your profile in the app, we return the full lot of data that you have entered and told us about you. But when somebody else views your profile, because they're seeing you as part of because of the request that you sent to join their basketball match next week, that is returning an instance of a public profile, which has a reduced number of fields, and also they don't have many of these nested fields that you can then just keep on nesting. So that's one of the things that we try to do to keep the response a bit more flatter, and also reduce the amount of nesting, and also prevent leaking, possibly leaking data to other people. So this one query is able to return all the information I need to see in my profile. And when you see other people's profile, you're looking at the data that's available through their public profile only, which again removes a lot of the sensitive data, that at least the PI data that can identify you. So AppSync itself is very scalable. They are GraphQL. They also support the GraphQL subscriptions, so you can build WebSockets, you can do all of that, and the subscription implementation can support millions of connected clients. And your AppSync API is automatically deployed to multiple data centers out of the box. So that also gives you a very good baseline for resilience. So even if one availability zone or data center is having trouble, then you still wouldn't impact your application. And you only pay for what you use. You pay $4 per million GraphQL requests. And so in that request to fetch all my information to show on the UI for my profile, that just counts as one request, even if behind the scenes it's making lots of different calls to different services to fetch the different data from different DB tables and so on. And one of the really powerful things you can do with AppSync is the fact that, as I mentioned earlier, it supports caching out of the box, which does charge you extra. Essentially, you're going to be paying for uptime for a memcached node. I think Redis node instead. Sorry, but you don't have to manage the Redis node yourself. It's fully managed, and it also has got built-in monitoring support with CloudWatch and the CloudWatch logs as well. So you get some high-level metrics for your API, like number of API requests, error count, and latency, which is great. But unfortunately, these are all aggregated, so it's difficult to tell if you're seeing some performance issues, whether or not that's caused by a single resolver or if it's something that's more systemic. And especially when you have a complex query that can involve many resolvers, you really want to be able to drill down to specific resolvers when there's problems in performance, but also just in terms of errors. So what you could do in that case is you can enable logging, which is going to give you a lot more information about what's going on. So you can narrow it down to specific requests that took a long time. And you can also inspect the resolver logs for that request to figure out, where the problem is. And specifically for performance issues, you can also enable X-ray, which is going to show you what's happening under the hood, and show you that for this GraphQL request where the time has gone. And you can see that this single GraphQL query has resulted in quite a few different DynamoDB calls behind the scenes, and you can see whether or not which calls are made in parallel and which ones are made in sequence. And X-ray also shows you a service map so that you can get this high-level view of which services that your AppSync API is talking to, and over the last couple of minutes in this case, what's the overall health of those services. And it gives me all of this, and I don't have to manage any servers, which is amazing. And also, I only pay for it when someone is actually using my app. And in terms of authentication, as I mentioned earlier, we use a Cognito user pool, and I also set up an identity federation so that users can sign in using Facebook and Apple as well. And on the client side, we use the Amplify library to integrate with Cognito, which made things a lot simpler as far as authentication is concerned. And we also created this CMS app as well, which also uses Amplify on the front end to authenticate users against different Cognito user pool, one that's created just for the CMS because they're being used by different groups of people. And there's no obvious crossover between the two of them. So, one is being used by the founders and the university staffs, and the other one is actually used by students instead. And as part of for the founders, they are the admin for the app. They can onboard new universities, and they can configure the list of sports that you see in the app. And so when you're onboarding a new university, you have to send an invite to the admin staff from the university, and they get an email like this. We can make it a lot prettier, but at the time we just wanted something working. But essentially, they're going to get an invitation with from the app, email verification with from the app, and as well as an invitation code as well. So then they're able to log into the app. We've used their own set up the passwords and all that. More pretty typical stuff you find. And the CMS user that we created for them automatically will be added to a university group to identify them as university admins. So this is one more detail as well. Is we also capture, because now you got the CMS system being used by different universities. So essentially, you've got this multi-tenant environment. So we use a custom attribute to tell us which university that this admin user is for in the CMS, and this is passed along back to us in the API by Cognito when the user is calling the CMS AppSync API. So it doesn't matter. So we never actually accept the organization ID, if you will, from in the request. So it's always coming from the user's resolved identity. And the UI, depending on which group you belong to, will show you different options in UI as well. So if the founders are logging in, then they will see different options compared to, say, if a university staff is logging in to manage their university's profile. And one of the great things that AppSync gives you when you use AppSync with Cognito is that this kind of group-based authentication, where you want to allow certain actions to be performed by certain groups of users, becomes really easy to implement. So if you are the admin, which basically are the two founders, then you're able to call this you're able to call this get university query. You can fetch information about any university, but if you are a university admin, then you can only call this get my university, and which takes no arguments. So you can only get information about your university back, and you can't get information about any other university other than your own. And any GraphQL operations that we don't specify, we don't have a directive on, then any logged in user will be able to use that query, like the get upload URL to upload images and so on. And so moving a bit closer to the code, I use the Serverless framework to help me package and deploy my application. I used it because it's really mature. It's got a great community around it. And it's also really extensible and flexible. It's got a whole load of plugins from the community, and I've been using it for a while, so I was really familiar with it, and so I was able to really get something done quickly. In this case, I've got one repo for the whole backend, and everything is configured in the one Serverless YAML and deployed as one CloudFormation stack. So resource reference and all that is very straightforward. Even as the project grows, and to do my deployment, I just run one command, serverless deploy, and that's it. It's really straightforward. And then to make it easier for me to configure all these different resolvers I had with AppSync, which there's a significant amount. I think at the end we had probably a couple hundred of different resolvers in the across the two APIs. There's the Serverless AppSync plugin, which makes things a lot easier. And I was able to break up my APIs into different YAML files to configure them. And for each of these files, I say, okay, what Cognito user pool I want to use with this API, what's the logging setting, and also for the different resolvers, I can configure the data sources, where the data is coming from, and all that. And then I write my VTL templates, and the VTL is probably not everyone's cup of tea. It's the same language, the same templating language that Amazon already use, AWS already use for API gateway. So I have some familiarity with already. And I think the official documentation does a pretty good job to explain how the language works. It's not the prettiest thing, but once you get used to it, it's actually not so bad. But as the project grew, I pretty quickly hit the 200 resources limit, which is the maximum number of resources you can have in a single CloudFormation stack. And the reason we hit that really quickly, partially because I was following AWS security best practices, and I've got individual Lambda functions, and each function has got its own IAM role. So we're following principle of least privilege and all that. But that doesn't mean that you end up with a lot of resources, CloudFormation resources. So it didn't take me very long to hit this limit, which nowadays stands at 500 instead of 200. But for larger projects, you're still very much likely to hit that limit at some point. So this is where I was really lucky to find this serverless plugin called the Serverless Plugin Split Stacks, which basically allow you to split your big stack into lots of smaller stacks, and then you turn them into nested stacks instead. And each nested stack has a limit of 500 resources, but together that means you can have 500 times 500 resources in the entire stack. But with AppSync, with the different resources you also have to be careful in terms of not creating circular dependencies between the parent stack as well as the nested stack. So this is where it's great that the plugin lets you write your custom script. And I've got a script that I use for multiple projects now, which splits resources based on the resolver. So you go from resolver and make sure that the resolver's data source and Lambda function and anything that Lambda function depends on, like log groups and things like that, and IAM roles are all part of the, or are always part of the same stack. So there's no external dependency that you got to go back to the parent stack for. So that's how we make sure that there's no circular dependencies. And then in terms of CI/CD, the whole thing was stored in GitLab. So now we just decided to use GitLab CI/CD because of that. And one technique I've used for pretty much all my projects is to install the serverless framework as a dev dependency, which means CI on CI side of things, I've got no dependency on the OS. I can just run npm CI to restore all my dependencies, and then just run either do this or npx serverless deploy and to deploy my project. So my CI/CD script is just super simple. Testing wise, one of the things that change, that's I guess one of the challenges with using something like AppSync is that it's kind of a black box. It's hard to test it locally. Saying that, just today they just announced a new thing, a new API that allows you to unit test the resolvers with API call or SDK call you can use, which I haven't looked at yet. But what we did at the time was for the resolvers, the VTL template. If I'm writing something that's more complicated, then I can write unit tests against it locally. But for most of the time, for most of the VTL templates, they are really straightforward. It's just a JSON blob, so I don't write any custom logic into that. Partly because I don't use the single table designs, so my VTL templates are just really simple. So I don't actually bother writing a lot of unit tests for them. As for my Lambda functions, I like to test them locally. So I run the function locally, but having them talk to the real AWS resources like DynamoDB tables and things like that. This is where what I would call integration test, where I test my function code locally against remote resources. And to make this kind of more feasible, because you do need a database there to be provisioned first. So we use a lot of the things like temporary stacks. So when I'm working on a feature, I would deploy a temporary environment like, feature number 2. And I would, that would create a DynamoDB tables. And after that, as I'm iterating on my code, I don't have to do a deployment every single time when I want to test my change, which could be, 2 lines of code. So it'd be silly to wait for full deployment before I can test it. But I do have quite a bit of an end-to-end test, which executes user stories, if you like. A user will log in, they will update their profile, and then they will look for other people's activities, and then they will try to ask to join those activities. So write those as end-to-end tests, which will actually call the deployed API endpoint in AppSync, and you would check the conditions of the data of the response, and then make subsequent calls and see if the world view is consistent as you make these changes across multiple API calls. And if you've got any failed end-to-end tests, then great. You can use them as a valuable rehearsal for how to debug problems in production. If you find that this process is difficult, then guess what's going to happen when you do have a problem once the system is live. So use that as a signal that you need to improve your logging, how your monitoring system, whether or not to enable X-ray tracing. So if you're struggling to debug problems in a controlled environment like end-to-end testing, then you're going to have a much bigger problem when this thing is in the wild. So don't optimize for your comfort with running local simulators like local stack. I think it just gives you a false sense of security. In terms of the AWS organization itself, setting this up can be difficult, but luckily I use a tool called org formation, which gives me infrastructure as code for the organization level things, and is used a syntax similar to CloudFormation, and I'm able to sort of template not just the different accounts I have and put them into organization units, but also create my template my landing zones, and allow me to easily reference resources from different accounts for CloudTrail, shipping all the CloudTrail logs from every account to an audit account and using, creating VPCs and KMS encryption keys and things like that. So that's pretty much my tool set. The main tools I use for this whole thing: Server framework for deployment automation, AppSync for the managed GraphQL, and automation for managing the AWS organization. So if we go back to the goals I had when I started out, small team, we got pretty much everything done, at least the first version of the app, within 4 weeks, with me working just part-time. In terms of speed of development, definitely a check there. AppSync can scale to millions of users. The app's been live for a while, and the client's been really happy in terms of how scalable this thing is. We have 0 EC2 instances, so no server to manage, no networking with VPCs and any of that. So minimum uptime, minimum upkeep. In terms of cost, when we went live in the first month, we had probably about 15,000 organic installs, and we're getting about a couple 100,000 requests a day. Our AWS bill at the end of the month was about $60, which is pretty reasonable for a small app like this. And the thing is, most of that is actually just going to the AppSync caching, because you're paying for uptime for that cache node. So minus that, everything else together is only about $20, including all the different API calls, AppSync, which I think in this case was a couple of dollars, and for DynamoDB was about $4, because I'll talk about that in a minute. So in terms of cost efficiency, again, clients really happy. Performance really good as well. Pretty good performance. Part of that is we got in this case, I think you see the 99th percentile is pretty much all the way under a couple hundred milliseconds, and part of that is because we had a really good cache hit rate. I spent quite a bit of time configuring the parallel resolver caching, and we're able to sustain a 99% cache hit rate pretty much throughout 24 hours. So performance-wise, that really helped. So that's the end of the talk. As I mentioned before, me and Gerard got this AppSync course, so go check it out at the appsyncmasterclass.com. But otherwise, thank you guys so much for staying with me today, and I hope to meet you guys in person next time.